If you're ready to do math today and you have your coffee ready, join me in the simultaneous sip.
The question we're working on today is, how many subsets of the numbers 1 through 2n do not contain two elements whose difference is 2?
Smash that like button and let's get started.
This is a really cool problem, so I hope you try it on your own before you watch me solve it. So what we'll start with is we'll write out a few of the small cases just so we can get an idea of what's happening here. So we'll have n, then I'll write out the subsets, and then we'll count the subsets. So when n equals 1, the possible subsets are, well, the empty set satisfies the property, 1 satisfies the property, the element 2, and 1, 2. So all of these subsets satisfy our property, and there's 4 of them. Maybe that's not too interesting. Let's try n equals 2. So the n equals 2, again, we'll have the empty set, the set containing just 1, the set containing just 2, the set containing 3, and the set containing 4. So all these single element subsets satisfy it. And again, 1, 2 satisfies it. 1, 3 does not, right? That's our first one that doesn't. 1, 4 does. 2, 3 does, but 2, 4 does not. And then 3, 4. And you could check that no 3-element subsets or 4-element subsets will satisfy our property. If we count these up, we get 9. Okay, so the first fact that we have to recognize is if two numbers differ by 2, so if the absolute value of I minus j is equal to 2, so if their difference is 2, then they're either both even or they're both odd. Right? You see that? You can't have two numbers differ by 2 and have one be even and one be odd. So that's going to be our first key observation. They're either both even or both odd. So we're going to take our subset, so any subset of the numbers 1 through 2n, and we could write it as a union of the even components and the odd components. So here E will be a subset of 2, 4 up to 2n, so the even numbers. And O will be the subset of the odd numbers, 1, 3 up to 2n minus 1. So now really what we want to do is to count how many even or just odd subsets there are. And this is equivalent, so just if we fix it to, let's say, even, to counting the number of subsets of the numbers 1 through n that avoid consecutive numbers being in the subset. So we want to count the number of subsets of 1 through n that contain no consecutive numbers. Right? And that's the same thing as having a subset, the even subsets containing no elements that are 2 apart. Let's call this number a sub n. And now let's find a formula for a sub n. Once we find the formula for a sub n, we'll square that to give us our answer. Right? We square it because it's even times the odds. So a sub 1 is 2. It could be the empty set or just the set containing 1. A sub 2 is 3 because it could be the empty set, the set containing 1, or the set containing 2. The set containing 1, 2 has consecutive numbers, so we wouldn't count that. And now, in general, each subset of 1 through n either contains the number n or it doesn't contain the number n. And this is a classic technique in combinatorics. Okay, so each subset either contains or doesn't contain the number n. If it contains n, well then we can't have n minus 1 in our subset. But we could have n minus 2 in the other ones as long as they don't have consecutive numbers. So there's a sub n minus 2 possibilities. And if it doesn't contain n, well, then that's the same thing as having a subset of n minus 1 that doesn't have consecutive numbers. So there's a sub n minus 1 possibilities. And these are disjoint, so we could conclude that a sub n is equal to a sub n minus 1 plus a sub n minus 2. This recurrence may look familiar to you, with a sub 1 is equal to 2 and a sub 2 is equal to 3. Well, what is this recurrence? It's exactly the Fibonacci recurrence, but shifted. So a sub n is equal to the n plus second Fibonacci. And so therefore, we can conclude that the number of subsets of 2n that don't contain any elements that differ by 2. So the number of subsets of 2n that have no 2 elements whose difference is 2, this is what we're trying to count, is Fibonacci, the n sub second Fibonacci squared. Make sure to subscribe for more Coffee and Math with Dr. Wesselcouch. Don't text and drive. Bye-bye.